Okay, so we are going to talk today about surface area and volume of solids. Now, often people will say, oh, that's so hard, or I'm not good at that, or whatever. We're going to break it down today to make it make a little more sense than maybe what you've had in the past. So I know that in the past you've been given like these complex formulas and been like, memorize this and, and then plug these numbers in. But it's actually a lot more simple than that, okay? So when you have a solid and you're looking for surface area, what does surface area mean? Like, what would you think that would mean, surface area? The area of the outside surface is what surface area means, right? And when you have these shapes, like what we have right here, all you've got to do is find the area of the individual surfaces and then add those areas up. So like if you look at this, they tell us this is 12 and this is 10 and this is 12. Well, if that's 12, then that means this over here is also 12, right? Right there. So this front is a square. And how do we find the area of just a square? So we would do 12 times 12, right? But we don't just have a front square, we also have a back square. So how many of those little squares do we have? We have 2 of them. So we would do 12 times 12 times 2 because there's 2 of them, right? The front one and the back one. So that's going to be 144 times 2 is what? 288? Okay, then we're going to find the area of this side. So this side is 10 by 12. But there's not just one of them. There's 2 of them, one on each side, right? So we would do the area of that next side, 10 times 12 times 2, because we have 2 of them. So 10 times 12 is 120 times 2, 240. Is that right? So we found the area of the front, the back, this side, that side. Now we got to do the top and the bottom. And the top and the bottom are the same. So we would do the area of the top. So it's going to be, it's 10 this way and it's 12 that way. Well, look at that. We just did that one. We don't even have to do the math for that because we've already done it one time, right? And then we just add up those 3 areas and that gives us the total surface area of that shape. So the surface area of this shape is going to be 8. And see, 4 and 4 is 8. 8 and 8 is 16. So carry my 1. So 2, 4, 6, 8. So that's the total surface area of that shape. Did I add that wrong? 7? My bad. Good catch, though. Good catch. I just did that to see if y'all's paying attention. Now, if we're going to do volume for that shape, volume for anything is you find the area of your base, whatever that is, and multiply times your height. So if we're going to find the area of this base, that would be 12 times 10, and then we're going to multiply times our height, which in this case is also 12. So this is area of the base, and then times the height. That's all it is. So you memorize this formula of length times width times height, right? But what is length times width? Always. Like, what is length times width? Huh? Like, length times width. What is that? It's the area of a shape, right? That's what length times width is. So anytime you're talking about volume, all you're doing is area times height. So in this case, if we did 144, because I know 12 times 12 is 144, times 10, that means we just add an extra 0 on it, right? So we've got 1440. But because we multiplied yards times yards times yards, our unit of measurement is yards cubed, because we multiplied yards times itself 3 times, right? Does that make sense? Okay, so if we're looking at the surface area of this shape. So we have to find the area of this side right here. There's not two of them, there's just one. Do y'all see what I'm saying? We have to find the area of this side over here. There's just one of them because this is not equilateral, right? Then we have to find the area of the front and the back. Those are going to be the same. And then the area of the bottom. So we have to find 4 different areas for this one, but we just add those areas up. So how would we find the area of this side right here? 5 times 6. That's going to be 5 times 6. 30, right? And then we have to find the area of this side over here. That's kind of hard to see, but we know that it is 5 inches wide and it is 8 inches tall, right? So 5 times 8. 40. Then we need to find the area of this front. Now, this front is not a rectangle. What is it? Triangle. So how do you find the area of that triangle? Length times, no. Well, base times height, length times width, right? So base, our base is 10. Our height, we don't actually have the height. We're going to have to do a little work to find the height here, right? Or we could reevaluate the way we're looking at it. Does anybody think about that? We could turn this, right? Not call that 10 the base. Call this the base, or that, either way, and have 6 as one and 8 as your other. Y'all see how we could do that?
That's smart.
And that way we don't have to try to find a height in the middle of this. So we could do 6 times 8 divided by 2. But what are we going to turn around and do because there's 2 of them? We're going to multiply times 2. So do we actually need to divide by 2?
No.
Do y'all see what I'm saying? So we don't need to make extra work for ourselves. So there's no point in dividing by 2 because you're going to turn around and multiply by 2 because you have 2 of the exact same triangle, right? So what is 6 times 8? 48. And now all we have left is to find the area of this very bottom piece. And what's the area of it going to be? 50, because it's 10 times 5. So then we just add up 30, 40, and 50, and 48. So 30, 40, and 50, that's 70, and 50 is 120. 120 and 48 is going to be 168 inches squared, because we multiplied inches times inches times inches to get inches squared for every one of them, right? That's not bad, right?
Yeah, it's not bad.
Now, when you have a wedge and you're doing volume, like this is a wedge, right? When you have a wedge and you're doing volume like this, you'll find the volume of, if this had been a rectangle, so if this went straight up like this, right, and went straight over like this, do y'all see it? So you would find the volume of what the rectangle would be, and then you're just going to divide that in half. And that's how you find the volume of a wedge. So what I would do if I was doing this is I would use this as my base, right? So I'd find the area of this base, which we've already done. What's the area of that base?
What base?
This right here. If I call that my base, that'd be 30, right? I'm going to multiply it times my height, calling this my height. Do y'all see? So I would do 30 times 8, and that's going to get me 240, right? But then I'm going to divide that by 2 because I don't have the whole rectangle, I just have half of it. Does that make sense? So 240 divided by 2 gets me 120 inches cubed. So see how we're not trying to memorize a whole bunch of different formulas and stuff? We're just using some logical reasonings with the formulas we already know to calculate volume, surface area, blah, blah, blah. Martha, you want me to go back over it? Because I don't mind. Okay, so here's what I did. I am going to call this my base because that one's real easy to calculate the area for. And so if I'm trying to find volume, all volume is area times height. That's all it is. So you're taking the area of this and you're saying, okay, if I have this area and I go up, 8 units, right? So I've got 5 times 6, that's the area of this, times 8, because that's how tall it is. But it's only, that would be for a full rectangular prism. But we don't have a full rectangular prism because the sucker's cut in half. So since it's cut in half, we then divide that by 2. So we've got 5 times 6 is 30, times 8 is 240, and then divide that by 2 because we only have half of that rectangular prism. And that's where we get that 120. Does that make sense? Okay. Okay, so look at this cylinder here. So surface area of a cylinder. Everybody wants to make this so complicated and try to memorize formulas and all that. Y'all, what is the cylinder made out of? What shapes is a cylinder's surface made out of? Circles on the top and bottom. We know how, and they're the same. So we know how to find that area, right? So how do you find the area of a circle? Pi r squared. And so in this case, what's our r going to be? Our r is 6. How do we know it's 6? Because they're saying it's 12 all the way across, right? Divide that by 2, and that gets you 6. So 6 squared. So that's going to be 36 pi, which is what? 113.1. But we have 2 of them, right? So we have to multiply that by 2. And what do we get? Okay. So that's for our circles. Now let's talk about that other shape. So that other shape that goes around the can. I want you to think of a can of vegetables. What's your favorite can of vegetables? Anybody like canned vegetables? Peas? I'm a green bean girl. I like green beans out of a can. If you take a can and you cut the label and you peel it off and you lay it out flat, what is that label going to look like? It's going to be a rectangle. That's all it is a rectangle. And if you think about that rectangle, what is the length of that rectangle flat on the can? So just think about that for a second. It's on the can. I wish I'd thought to bring a can and I didn't do it. What about the circle? So here it is, right? It's the circumference. Y'all see that? Do y'all see what I'm saying? So if we lay this label out flat, it's the length of this rectangle. But if we roll it up, what is it to the circle? It's the circumference. So if we want the length of this rectangle that we've got going on here, we need to find the circumference of the circle. Do y'all remember how to find the circumference of a circle? 2 pi r or pi times diameter. Either one works, right? So what is that 2 pi? What's our r? 6? Or we could just say 12 pi because our diameter is 12, right? So that is the length of this rectangle is 12 pi. And we're going to leave it as 12 pi for just a second. Okay? How tall is this rectangle? 10. So we're going to multiply 12 pi times 10 to get the area of the rectangle. So what is the area of that rectangle? $276. So now is that what you said? $376. I'm sorry. I can't hear very good today. All these allergies got my head all kinds of clogged up. All the pollen. 377. Okay. So we got to add these two numbers together, right? 226.2 is our circle. 377 is our rectangle. We add those together, and that's going to get us our total surface area. So it's going to be 2, 7, and 6 is 13. That's going to be 10. 603.2. Is that what y'all got? And, of course, it's area, so it's inches squared. So that's how you find your area. Your surface area. Now, remember I said earlier, volume of any shape. I should have gave a caveat. The only difference in this is if you're talking about cones. Cones is not the same. But volume of any shape is your area of your base times your height. Right? That's all it is. We already found the area of our base. That was 113.1. Right? So if we take the area of our base, 113.1, and we multiply that times our height, 10, that's going to get us the volume of this cylinder. 1,131 inches cubed, because it's inches times inches times inches. Right? This was inches squared. This is another inch, so inches cubed. Does that make sense? Where'd I lose you at? This 113, that was the area of the bottom of our shape. So anytime you're doing volume of any shape, you're just taking the area of your base and multiplying times your height. Now, the official... Does that make sense? Oh, you didn't write it down? Gotcha. So, the official formula for the volume of a cylinder is volume equals 2 pi RH. That's the official formula. But all this is that's area of your base, that's your height. Y'all see what I'm talking about? Oh, I just wrote that wrong, y'all. It's pi r squared h. That's the area of your base. Okay. What about this guy? What shapes do you see that we need to find the area of? Hexagon and a rectangle. And we actually skipped finding area of hexagons yesterday. Probably shouldn't have done that and then put it on here. We're going to skip this one because we didn't talk about, we talked about it briefly, but not enough for y'all to be very good at it, so we're going to skip that one. You ain't going to see that anyway. So I'm not going to put that on there. Okay. So what about this one?
Which one?
This guy. So they actually should have given you a little information that they didn't give you. They should have told you that these were congruent. By knowing that those four are congruent, you know that the bottom is a square. If the bottom is a square, what do you know about all four sides of that? They're all equal. Now, to do the surface area, we have 4 equal triangles to find the area of, and then this square on the bottom, and we add those two together, right? So what is the area down here? 16. We did 4 times 4 to get 16. That's the area of our base, right? And then how do we find the area of each one of these triangles? Base times height divided by 2. And we're going to go ahead and divide by 2 this time for a reason. So base is 4, height is 7, divided by 2 gives us 14. So this is the way I did that. I did 4 divided by 2 in my head, which gives me 2. And then 2 times 7 is 14. Does that make sense? Now we have to multiply that times 4 because there's 4 of those triangles. So 4 times 4 is 16. Carry my 1. 4 times 1 is 4, 56. And now I just add 56 and 16. 72 centimeters squared. Now, remember when I said the volume of any shape is area of the base times the height? But then I said I should have given a caveat on that. Well, these are the two shapes I should have given a caveat for. Do y'all know what caveat means?
No.
So, you're going to learn a new word today. Caveat is like, it's like saying, it's always true except for this instance. A caveat's like a exclusion to a rule. Okay? So, anytime you're dealing with a cone or with a pyramid, to find volume, you do the area of the base times the height, but then you're going to divide that by 3. Because if you were to make a rectangle out of that, it's actually taking out 3 parts. Does that make sense? So, the area of this base, we already found it, was 16. The height of this, we're going to have to do a little work on. But it's not going to be real hard work. But you've got to do a little visualizing. Can you see that if we put a line right down the center of this guy right here, that we have a right triangle? Can you see that? Can everybody visualize that little triangle in there? Let me see. Can y'all see that little right triangle inside there? Do y'all see that guy? See how it comes down and it's a right triangle? Y'all see what I hear Esteban saying yeah. I don't hear many other yes. So I'm just trying to make sure everybody gets what I'm saying. Do y'all see it? That right triangle? So that right triangle right there, we know that this side of it, this side I'm tapping right here, on our shape is 7. We know that this part at the bottom that you can't see my hands on, y'all see where that little slit is right there, right? That's 2. So that part's 7, that's part's 2. Can we find that part that's going straight up? What would we use to find that? Exactly. So we know on that little triangle that we have, this part is 7, this part is 2. We need to find this. And it's either A or B, whatever you want to call it, right? So we would do A squared, let's call it A, I guess. A squared plus 2 squared equals 7 squared. And then we just find that height. So that's going to be 49. That's 4. So A squared is 45. Y'all with me so far? Then we're going to take the square root of that. So what's the square root of 45? $6.7. So our height is approximately 6.7, right? We already found the area of our base. That was 16. So we're going to do 16 times 6.7, and then we're going to divide that by 3. And that will give us the area of the volume of the whole thing. So what is it? Did I lose anybody? You guys just bored? Just sleepy? This 16, because that's the volume or the area of the base. The base is 4 times 4, that's 16. So 16 times 6.7 divided by 3. 35.7. What's our unit? Cube, because this was squared here, right? This was squared, but then this is also centimeters, and we're multiplying by another centimeter.
When you did the formula of the
this is 4 from here to here, because this is 4, right? So because this is 4 right here, it's 4 all the way across in the center also. So half of that, because we're going straight to the center, is 2. That's where that comes from. So, this is one of those things I'm just going to ask you to trust me, because I don't have any way of proving it to you. But if I take this and I make a rectangular prism with this height, with this base, and then the same base down here, this space that's taken up is 1/3 of that rectangular prism. So when we found this volume right here, that would be the volume of a rectangular prism with that size of a base. And then the reason we divide by 3 is because that pyramid only takes up 1/3 of that space. And I have no way of proving that to you. Just know that it's true.
So it's like if you put 2 different together, and also another space inside.
Yeah. Yeah. And like I said, I don't have any way of showing it to you. Like I normally try to show you things like that, right? But this one I can't show you. I don't have any way of showing it. So just know that I wouldn't lie to you, okay? Huh? I wouldn't lie to you. Okay. Now, let's talk about a cone. Do you know what?
Oh, he said, do you know? I said, I.
Yeah, so have you ever y'all know those drumsticks with the chocolate down in the bottom of those are like my favorite. That chocolate is the best part of the whole thing, right? Have you ever taken a wrapper off of that without ripping it all the way up?
No.
You've not ever taken a wrapper off without ripping it all the way up?
Yes.
I'm going to see if I have a net.
Explain it to me. Like opening it, when you open it, like a bag of chips, opening it, so it doesn't rip all the way.
Okay, here's a cone, right?
Yeah.
Do y'all know what a net is?
No.
So a net is like a 2-dimensional shape that shows you the surface area of a 3-dimensional object. So this is a net right here. I actually have a solid this fits down in, but when I open this up, it's going to be flat. But it's going to be more than one shape, right? It's going to be some pieces put together. So this is what we got.
Oh, can we do this? It's like a birdie too. Like a. That's like an
Yeah, we talked about this earlier this year.
with the cylinder.
Uh-huh.
Yeah.
So, this is a net of a cone. Do you see that piece of cone right there?
Yes.
So this piece right here, this is what makes the cone shape, right? So, if I were to take a protractor and I'm going to try to do this.
That was cool. That's the birdie.
It does look like a bird, don't it? I'm going to draw this angle out. Okay, so that's the angle that the cone makes right there, right? That's the angle. This is the cone piece. This is the non-cone piece. right? This is absence of cone. No cone here. No cone here. Right? Cone here. Okay? So if I measure this angle, that is no cone here. So I measure from this side over here. Those are not glasses. I can't tell if I'm getting it on there. Am I?
Oh, we do.
Not. Okay, so I measure from this side over here. So I start at 0, go all the way around. Look what it is. It's 160. This angle is 160. So what is this angle? If this angle is 160, what is this angle? So we would do 360 minus 160. We get 200. Now, what is 200 out of 360? Like if we simplify this, point what? Can you make it a fraction? Just since we're talking about it anyway, this is what you get, right? But if we make that a fraction, hit math, then hit enter, then hit enter. Now, do you think that that's going to be the same every single cone? Is it always going to be 5 knots?
Oh, no. It's an extra question.
Oh, well, yes. Actually, I really don't know.
You feel like it should be?
My answer is I have no clue. No, you shouldn't have done that.
Let me see if I got some more. I got another box.
I think it always.
You think it always is?
Yes. Why?
Arnie,
What if it's kind of sticky? Oh, you're like, I'm thinking. Oh, you got it. You're thinking that.
Who takes with my ball? Y'all think this is the exact same cone?
Huh?
I'm 99% sure this is the exact same cone.
It is. It is. Looks like it.
It is. All right, let me see if Mr. Lester's got one, okay?
You saw it. Bags it on top. Just take off the good. Oh, this was good to the dog.
Okay.
Oh,
You don't have a net either. I should have planned better. I should have made some, but I didn't do it. Okay.
It's what number? It's over this way.
I apologize. I didn't. I didn't plan good enough for this.
Yeah, he said, it's so hard to throw at you. Right. I was just ready to talk about it. With the girls. That's pain. With the girls. That's pain.
Hey, Fernando, since you're up roaming around, bring me a pair of scissors and some tape. Scissors and tape, please, sir.
He went over there, she threw it through, he got tucked up in the sand. That's funny.
You are awesome. Thank you, sir. Okay, so I'm going to try to make this work.
Yeah, I don't think I'm supposed to have babies on there, but enough circulation.
Good. That's what Amos said. Amos said, I'm telling you, it's fun.
Okay, so I sort of covered it. It's not perfect. I didn't have a big enough paper to completely cover it all the way. But we'll get a decent idea of what it looks like. So I'm going to pull it off, right? And I'm just going to slice it straight up to the point.
Straight up.
So it's straight up to the point. And then there it is. Okay? Does everybody see it? So if we measure this from the center to the best of our ability, should it? Because it is not. Of course, my thing may be wonky.
That's a great question.
Is it 160? Is it 160?
Like 125.
But not 160. When we did this one. I know, because I did it on white paper and I'm laying it on top of white paper. I should have used colored paper. When we measured this one right here. That one's 160. This one is not 160. Should it be? That's the question we're asking. Is it the same? No, it's not going to be the same. It's not going to be the same because it has to do with how big your bottom is and how tall your thing is. The taller you make your cone relative to your base, right, the more area you have to cover. So like if I take is that the same one? Crap. Mr. Lester and I have a lot of the same things. That's his box over there. This is my box. No. A different thing, not this. Not this. A different thing. But yes. Is that the same? They're the same. Why do we not have any different cones? Why are every cone we have the exact same cone?
That's a great question.
Look at this.
Let's go get an ice cream cone from the cafeteria.
Oh, I was telling you. They have chocolate jabs.
What time is it, y'all?
32. That's that time.
We got 3 minutes.
That's time.
All right.
Save.
Pack it up. We'll finish this up next week. Link,
Lance in your trouble.
do you feel a little better about search series?
Yes.
Look at this one, honeycomb.
This one got a tiny cone.
What?
We're gonna have like 6.
You think it's gonna be bigger?
It's gonna be smaller.
Think it's gonna be smaller?
He actually wrote it. I wonder what that. Bro, I'll say, I beat him. I beat him. I bought him trash. And he beat me. And then he got 8th grader. I knew he wasn't good.
Honestly, Bob got 8. Every time you ask him on 5 teams, it's not. That's probably all
Tiny cone.
Oh, you found one. But you can make it.
No, I found it. See? Tiny cone.
I saw the scissors, so I can make it.
Look at this one.
There's another tiny cone.
It's this. So look at this one. The angle of this cone. Y'all see?
Oh, this goes inside of it, doesn't it?
Yeah. Alrighty. I see y'all Monday. Have a wonderful weekend. Bye, buddy.